I'm the Director of Technology at Temasek, and I'm also a committee member for the Free and Open Source Society at SCS. I've been an avid open source proponent throughout my career and have worked in tech roles across various industries, including animation, gaming, and government technology. So a quick intro about the free and open source chapter of SCS. We are a bunch of open source advocates organizing events to promote awareness of innovative and cool open source technologies. We also organize events to share new trends and use cases with fellow tech professionals like you. Our speaker today is Hunter Neal. He's a distinguished engineer at GovTech, where he helps guide cloud strategy. Prior to joining the government, he ran businesses in Asia and Australia focused on cloud infrastructure, digital transformation, and R&D. Hunter unusually holds a degree in visual arts. He started his career in user experience design before shifting to web development and cloud infrastructure. Even with his head high in the clouds, he remains passionate about design and developer experience. So the topic today is very relevant and very timely for us. It's on service mesh. As we transition from monolithic applications to distributed microservices architecture, the challenges in managing the networking, the security, and the interactions between the microservices keep growing and keep becoming more complex. So we can hear firsthand from our expert here today with Hunter on how we can address some of these challenges and learn a bit more about service mesh. So before we jump into our webinar, some quick housekeeping rules. So the session will be recorded. So please turn off your video and mute yourself for your privacy. You can ask questions in the Q&A box, which you'll see at the bottom of your Zoom screen. And we will take some questions towards the end of the session. So thank you very much for your participation, and over to Hunter now.
Thanks very much, Parimal. I would have to say I am by no means an expert in this. I'm just on the journey of discovery, but you know, I've been working with various different technologies such as service mesh for the past few years. So hopefully there's a few insights that I'm able to share with everyone. So without further ado, I guess there's a lot of discussion about sort of service meshes and or the mess that we see with these microservices and application networks. So let's go into a little bit of detail about that. So if we stretch our mind back, a long time ago in a galaxy far, far away, I think this, in fact, probably seems quite familiar to a lot of people. In fact, it may not be that far long ago. If we're familiar with, typical three-tier applications, back in the day, if we're thinking back to a data center, then, we're very much focused around, single servers, segmentation into these sorts of logical zones, these web app and DB tiers, if you want to call it that, and very much so static IP addresses. If you go into a data center, it's very much that there is a static IP allocated. It may be actually given to you out of a spreadsheet. So, these are the sorts of things that are still very much in practice in a lot of industries and a lot of environments. But, as we start to see, these things are changing as we go forward, especially with the cloud. Now, if we take a little bit of a deeper look, as we have our application environments, we're very much breaking these sorts of things down into the perimeters that we have and, the segments and the IP addresses that were allocated. But, in between those tiers, we see that we have, these sorts of firewalls that are there to secure access between the tiers. The load balancers that potentially balance between, perhaps highly available apps that are sitting in the application tier. Now, as part of that, the core things that we really look at are, these sorts of things that IP becomes the identity for our services. How many times do we sort of look up and say, okay, IP address, 192.168.something.something is our database server. And then that's, its entire identity for the rest of time. We can't change those things. The firewalls become, critical pieces that map the flows between these IP addresses between the different tiers. But the load balancers themselves obviously are really keeping track of these applications or IP addresses that are running between them, and used for sort of discovery and health checks to make sure that if something falls over, we're not routing to a potentially unhealthy node. And at the end of the day, all of these sorts of things are typically managed by a network operations team who are there to hand things out and to manage them in a way, because there is an element of complexity, but also security that's baked into these sorts of environments. So as we move away from our on-prem data centers, and into the cloud, we start to see that things change quite fundamentally. We move away from these sort of fairly fixed environments to ephemeral virtual machines, dynamic IP addresses that are allocated on launch and potentially may not be the same if you restart. Auto scaling up and down to make sure that these applications are both highly available and also scaling to the needs of the environment and the traffic for the business. So a lot of these things ultimately becoming software defined and API driven, which means that there's a shift from what we typically see as network operations teams into the development teams. This is where we start to see the mention of sort of DevOps as a buzzword or as a process in organizations. So as we start to really scale out our applications, the cloud becomes this enabler of so much of what we see in modern application development. We're starting to look, easily scale up to much larger application sizes, and we're seeing much more adoption in the services that are available both in the cloud and by pure number of virtual machines or various different components in the architectures themselves. We're also really splitting services based on domain. So rather than the typical monolith, we start to see that we are kind of looking at areas in our applications that may be split by business units, by different teams that are working on particular functionality, or by scaling domains for those areas that may be potentially more of a bottleneck than others that need to be split out into different areas. But the trade-off is then that especially when we're in the cloud and on-prem, the networking gets very, very complex. If we look at, the cloud service providers, we start getting into the complexity of peering, we start managing, the virtual firewalls and, all of these sorts of complexity that really starts to grow out of that as well. And, although we like to say we're going from a complex on-prem data center into the cloud, it should make things easier. Effectively, we're adding just a different set of constructs, which we need to understand and learn. So as we start to get into what we like to call microservices, the explosion of services growing out there, we get this even greater granularity of services in our environment. We're also talking about this sort of coordination that is reduced between these services so that one application team can deliver on a different schedule than another application team, and rolling out there without necessarily or ideally not impacting the rest of the services in the environment. The traffic flow actually changes itself. So what we typically see in these sort of three-tier applications is we have very strong north-south traffic coming in from the public internet or elsewhere in the organization into the application. But as we get into the microservices, we start seeing what they call, what we typically call an east-west traffic, a favoring that area. So the movement laterally between these sorts of services behind the kind of core ingress into the network becomes probably where most of the traffic flow we see is going. And it proves a different challenge to what we typically see. We also see that there's this sort of explosion of new technologies like Kubernetes or containers that, change the model that we're typically familiar with. In the past, we would more than likely have a service per virtual machine or server. But now, as we see with Kubernetes, we can potentially have 100 services per server. And so managing that and coordinating that becomes incredibly difficult. And, keeping the security up on all of those things becomes fundamental to delivering applications these days, especially in an enterprise context. So really it becomes a messy question at scale. What do we do with identity if we can't use an IP address? How do we discover these services if they're growing and scaling and changing, hourly, every minute of every day? And how do we manage this sort of connectivity between those services where, we can't keep track of every single firewall or load balancer that's running in our environment? These sorts of things have to be managed in such a way that's scalable and secure at the same time. So really what we're seeing is this evolution of technology that we've come, network has struggled to meet the needs of our compute environments. And there's this pressure, especially for network teams, to enable these new connectivity and reliability and resiliency requirements, of course, while maintaining security. So it's a bit of a tricky problem as we see this evolution in the way that technology is going. But at the end of the day, we need to be able to service this evolving mess. So let's get into a bit more detail about what is a service mesh. So a service mesh is really covering the service or software-driven approach to routing and segmentation. So trying to solve these problems that we talked about in this sort of evolution of scaling networks to many different services, be they microservice or macro service, if you want to call it that, and the cloud infrastructure that we're starting to adopt as well. These things also overlay additional benefits that we don't typically see in more traditional network approaches of things around failure handling and observability into the network traffic that we typically will see at volumes at scale, especially the east-west traffic. So, really, what are the key components? We start to see that we're looking at control planes and data planes as a fundamental piece of the service mesh. So this control plane is really that central coordination service, keeping state and remembering the services that are being registered, but also the policies that we use to manage the traffic. The data plane itself is really really the traffic that's running between our services themselves, but it's also responsible for the security and the connectivity and potentially the metrics and observability that we see for these services as well. So there is a very strong isolation, and this is really the only way that we can manage network environments at scale without having these sort of centralized bottlenecks as we've seen with sort of other areas or other technology that has come in the past. So, ultimately what we really are starting to do is seeing how we can take this service mesh technology and simplify our networks in some way. So, the routing and segmentation that we've typically talked about before gets moved from, centralized control, especially by an operations team, out into the edge, into the kind of the data plane itself. The network becomes the responsibility of connecting these services together. And for those sort of brave teams out there, the firewalls and load balancers can kind of be disbanded in some ways, since the network itself becomes very, very flat, and the service mesh does the routing and security itself. Now, I've seen no evidence of that actually happening. Partly because I think there is an element of sort of defense in depth and keeping these existing structures in place. But there are these sorts of areas that can be explored, even if it is just simplifying the number of different components in the network and the complexity that we're really starting to see. So here's a thought. So what if there was no IP in the network? How would services find each other? How would the services securely connect with each other? And how do you do failover and load balancing of these unhealthy services? So, it changes the model slightly. And let's take a little bit of, these sorts of key components that go into being, the fundamental piece of reducing the need for strong identity through IP addresses. So service discovery is really a fundamental part. I mean, it's, talking a little bit about the control plane before, it is really that central catalog of the services themselves, the metadata, be it the name or particular tags that we have associated with a particular service, and also the health itself. We don't want to be having something available in the network that potentially is down or is unhealthy. So this central registry keeps tabs on all of these sorts of things. And keeping it updated in close to real time to make sure that we're up to date and routing it in some ways. So in some ways, if this sounds a little bit like DNS, you're probably right. Although it is fundamentally enabled through some pieces of DNS. At its core, the update mechanisms are probably a different method because they store different pieces of data about these services themselves. So additional metadata, the health, all of these other parts that we see. So the other part is that if we're not really looking at IP as the core for our networks themselves, and it's not considered trusted as part of that, IP addresses come and go. Is it the right service that we're addressing? We effectively need to give these services themselves an identity. And one of those sorts of things that we see is a standard that came out of some work that Google did a while ago, and they used a variation of internally. This is called SPIFFE, or I think it's Secure Production Identity Infrastructure for Everyone Else, or something along those lines. But at the end of the day, it means a bunch of PKI certificates that are distributed to the services themselves, which contain a certain amount of information about the service so that they can coordinate between different services for security. So it establishes that trust for the services themselves without necessarily having a fixed IP address, using cryptography as a more secure means of doing that. So very important and very fundamental piece. And if you want to throw out another buzzword, it also kind of touches on that zero trust model of how do we make sure that the workloads we're talking to are fundamentally secure as well. As part of that, we really are starting to look at the segmentation of how these services securely talk to one another. And these really touch again as across the identities that we've already established, but also the connectivity between the services, the networks, and the access control policies that enable that. So this segmentation and the connectivity becomes a really critical piece. Effectively, we're looking at how we connect one-to-one services for things in a mesh, or sort of one-to-many for these sorts of things that we may consider as being load balanced. But it also touches on these things that we would like to enable that we typically see in our network environments of load balancing, failover, health checks, and all of these things to make sure that we're delivering a reliable network between these sorts of services. Now, a fundamental core piece of these is what are called sidecar proxies that effectively sit at each of the services themselves, potentially in the container or potentially in the virtual machine themselves, and provide the actual kind of the glue that talks between the services themselves. So it does mean that they simplify the configuration of the applications that we're deploying as our services, so that they don't necessarily need to know about, they don't have to speak service mesh. They don't have to necessarily have particular code that's specific for that service mesh themselves. They really just call out as they would typically between network services, and that piece is in between the sidecars is managed by the service mesh itself. So in some ways, it gives you some of these features for free. Obviously, that's a little bit of magic, but there's additional complexity that gets moved elsewhere into the network itself. So, this is a really core component, and we see that there's, this sort of need for these sidecars to be able to talk to the central control plane, to do that, to have that coordination, to be able to map the various different services that are live and healthy and routing traffic, and making sure that the services and the certificates themselves are valid as well. So as part of what we see, it's one thing to be looking at, specific protocols for this, but at the end of the day, because this thing has to be compatible, it has to provide a layer that, various different applications, be it a mainframe all the way through to a container or a functions as a service can utilize. These sorts of things need to be able to support multiple protocols. So fundamentally, I think layer 7 is probably the area that most of the microservices community is communicating at, HTTP at the base layer, whether or not it's sort of overlaying HTTP2 or remote procedure call protocols on top of that is one part. Or it could be at layer 4, where we see connectivity with databases, or tunneling other more unusual protocols or legacy protocols across a service mesh itself. So, there is this sort of breakdown about layer 4 and layer 7, if anyone is probably a little bit confused or curious. Layer 4 is really that sort of most compatible level. It's also giving us the highest performance, but it is, harder to do traffic management. It is harder to do inspection on the traffic as well, because at that level, it's mostly packets that we're starting to look at. At layer 7, we start to really bring things up again for the HTTP side of things. We're starting to look at a lot more about complex traffic management, load balancing, routing, these sorts of things. But it is, the trade-off is that it is generally lower performance, but it provides greater inspection and observability of these sorts of payloads that are running across these connections. So as we start to get into the more advanced features of what we see as being enabled by service mesh, one of those things is really the traffic management aspects of it. If we're managing microservices at scale and we're potentially rolling out a service that hasn't been tested in production, or may have things that cannot be tested because of the complex interaction or the dependencies in this environment, we can start to see that there's benefits in being able to have some subtlety in the rollout strategies, be it say a blue-green deployment where we just send a small amount of traffic to one particular service to test out if, and then roll over to a newer service for once we've confirmed that it's operating as expected, or these sorts of canary builds, if you want, that can target different headers or cookies in our connections to say, well, mobile traffic may go to one service and browsers may go to another service. So these sorts of things enable a lot more advanced use cases and flexibility for these sorts of environments as they start to grow out into scale. So as part of that, the observability aspect of it becomes fairly critical because these sorts of things are being, developers are really becoming the operators of these environments. They need to understand fundamentally as these sorts of things roll out, how they're performing and how they're potentially impacted in terms of rollout and also service health generally. The observability aspects of it become incredibly critical. So sidecar proxies sort of expose the metrics and logs and traces out to other services for aggregation and inspection, and also for debugging as things go wrong. So there's some really nice tools out there as well that enable a sort of both visualizations, but also traffic inspection and monitoring and health as a means of driving the efficiency of microservices, but general services as they start to adopt a service mesh approach to applications. So let's go into a little bit at a very high level about the tools and technologies. So, we talked about the sidecar proxy being a very fundamental piece of a service mesh. And if you go and look out at the various different service mesh products out in the industry, you'll probably find that probably 90% of them are using Envoy Proxy. Now, Envoy Proxy is a tool that came out of the car hire service Lyft, and has now been donated to the Cloud Native Compute Foundation. And it powers most of these things because it's a very, very powerful proxy load balancer, supporting both TCP HTTP in various different flavors and UDP as well. So, its real strength and why it was so well adopted was that it has a very, very powerful remote API that, can be dynamically configured over the wire from a control plane to enable, this sort of dynamic configuration. If you kind of think about, more traditional approaches to proxying or load balancing, many of them have static configurations. And so you see that the way that the industry is going is this sort of remote configuration and dynamic configuration. And the industry is sort of following on. So you see that Nginx is starting to follow along with similar functionality, or even the more traditional load balancing organizations are starting to have these dynamic configuration APIs to enable what we start to see in the service mesh piece. But Envoy has really taken the market as an early piece with other companies starting to offer very similar services. But in terms of the actual service meshes themselves, probably the biggest name is Istio. Istio, probably made the service mesh popular as it is. It came out of Google and a number of work that things that they have in their networks, specifically on the BeyondCorp and BeyondProd side of things. Although it doesn't necessarily match exactly, much like what Kubernetes is in the industry, it's an approximation of Google's network environment. It does really extend this to a more general computing environment and overlays very nicely, surprise, surprise, on top of Kubernetes itself. The downside a little bit is it's quite complicated, or at least has traditionally been quite complicated. There's been a number of moving parts that get deployed as part of Istio, although very recently, the operations side has been consolidated down into more single components that are easy to manage and easier, to, I guess, reason about for operators as well. For the application operators, because there's a number of pieces in managing a set of service meshes, that also the complexity for the application developers does, sort of overlay on top of that as well. So the management of how you roll out traffic for load balancing, or the connectivity or the TLS connections between services does get exposed quite heavily. And so in the Kubernetes context, it's death by CRDs in some way, as a joke that somebody made originally. The configuration files, the YAML files in Kubernetes is probably, if you install Istio into your environment, you probably end up with another 30 configuration objects in there, which I think is certainly improved recently, but still, doesn't help, at least for the perception. So still very worthwhile considering, because it is the most mature of the service mesh platforms out there, but it also quite complicated to manage. Outside of the Kubernetes environment, we see open source tools like Consul and Kuma. Consul is a service out of HashiCorp, for those who are familiar, and had a strong history in service discovery, but very recently started adopting service mesh technologies, and is actually a very reasonable general service mesh product, because it can actually span multiple data centers. The Kuma product is quite conceptually similar, but comes out of the work that is being done by the teams, and I've just had a bit of a mental blank at that, but API vendor Kong. So there's a very strong correlation between API vendors and service mesh vendors, I think. And I think that's something that is quite complementary and a really good offering in the market as well. The cloud providers themselves have their own offerings, and again, if you look at them deep down, again, they're all pretty much Envoy at the core, but they manage the control planes for you themselves. So there is less infrastructure to manage, and they integrate very nicely into the CSP services themselves, be it the observability and the monitoring and the logging tools as well. So it does reduce the complexity, although it is quite a specific implementation for the services, the cloud services themselves. So, there are, dozens upon dozens of service meshes out there. I think it's probably the new flavor of the year. Although I think there's probably ending up being some consolidation around those two. But it's quite interesting to see that, there are some standards that are being developed. The open or the service mesh interface is one that is starting to look at how various different service meshes can have a consistent interface independent of the implementations behind the scenes, but also a way of potentially interconnecting between different service meshes themselves. But still very much early days, and as a technology itself is still very much in its infancy in adoption for these sorts of things too. So very much worth exploring and seeing how it fits in with different environments. There's a lot of potential, I think, for growth as we go forward. So quickly, just in summary, service meshes are this this software-driven approach to routing and segmentation. It's really designed to solve the network and security challenges that we see as we start to see this explosion of services in our network environments. Now, it works both on-prem, it works in the cloud, and it does layer a lot of complexity on there. So I think probably really in summary, it may seem like magic, but again, it's very much just another technology that does need to be evaluated and does need to be considered in how it's being used. I mean, I think if you're still developing monolithic applications or things that potentially are at small scale, then a service mesh may in fact be too much. But as you start to scale things out, be it as for service meshes or between sort of various different data centers, there can be some benefits to be considering that the use of service meshes, but very much important that it's considered that it is another technology to manage and a technology to be familiar with, and it has a different set of failure domains, even if it changes how the networks operate and the control and the agility that we have in terms of developing and delivering our services. So with that, thank you very much. And I think we can probably start opening it up for questions, but back to you, Parimal.
Thanks a lot, Hunter. We already have a few questions starting to stream in. So I guess the first question is from Richard, which is like, when should one start considering service mesh capability? Is it possible to start building on a microservices architecture first and then put a service mesh in place later? Or when is the right time to start considering service mesh?
It's always a very tricky question, I think. It is very much business dependent, I think, and it really does depend on the scale of the adoption of of microservices, I think, in the first place. I mean, I don't think you necessarily want to run too far ahead and say, we've got our monolith, we're going to start carving it up, but we're going to get our service mesh in place first. That's probably leading the horse a little bit too far, but it's sort of where you draw that line to say, where should I have a service mesh, is when you start, if you are kind of carving out your service mesh, is there a point where the management becomes too much to say, we should really start adopting various different parts of it. Now, it can also be that you start adopting components of a service mesh before rolling it out in complete isolation. So say, well, we don't necessarily need to have mutual TLS between every service in our mesh, but we do want to get observability so that we know when we are starting to roll out our services that they're operating as expected, that they are giving the right kind of performance guarantees as we start to scale out. So there is this point between probably monolith to complete microservices that there is in that scale, but it's very much dependent on the needs of the business and the maturity of the organization itself, I think.
Okay. And maybe one question I have, like, do you still need firewalls and load balancers if you start using service mesh?
Well, that's a sort of joke about how much your risk appetite is there. I mean, I think you can sort of look at it as saying, well, there are important uses for firewalls. Load balancers perhaps less so, depending on the context and the services that you're running. But in some cases, you still want to be protecting for, the eventuality that somebody breaks out of a container, or the service mesh themselves potentially has a compromise, and you do want to be able to compartmentalize those environments in some ways. Now, that may be that you have, a virtual firewall or a security group in your cloud service provider doing that for you. And in fact, that's kind of layering sort of defense in depth, if you will. But overall, you still need to have some security hygiene for your network. But in terms of the connection between the services, I think that you want to try and get out of the way and let the traffic in across at least the familiar ports that you're familiar with in the service mesh itself, and enabling the observability and the security across those connections to make sure that the connections are in fact going to the right place and not being intercepted along the way.
Okay. So some questions from the audience. Is there an overlap between service mesh and API gateway?
So it's always a really interesting question, and I've had a lot of discussions about that with a number of different teams. And I think, there is an element of overlap, but I think where we start to really see API gateways coming in is really that, sits at the edge of our application, of our microservices. So, if you're talking to external consumers, that's where an API will live. That's the kind of the north-south boundary, if you'll talk about it. But as you start to get inside your mesh, because you're talking about services talking to services in that sort of east-west connection, that, really, the service mesh makes sense in that point. Now, you're still talking about APIs, but potentially the APIs themselves may be the responsibility of the individual services themselves. They may be embedded in the application. So it's less about the sort of the interface and the specifications that you have that you would live in an API gateway. It is very much more about the internal communication. So if you are talking about it as sort of externally communicating out to the world, then the API gateway would live there. If you're talking in between your teams, between services, although you will probably have specifications or protocols that you're talking with, it is very much internally publishing in between those sorts of things. And that's where I think a service mesh fits quite well.
Okay, thank you. We have one more question on so who is in the best position to manage these? Is it the network team, the server team, or operations?
So I think there is always a little bit of an overlap in that. And I think that's what you start to see as you move into the cloud a little bit. And as you start to see these technologies like Kubernetes, is that you get this kind of layering effect where, although we'd like to kind of say everything's DevOps, it's not necessarily always that cut and dried. You still probably need to have good, strong knowledge of networks to be able to, run your applications at scale. You also need to have good developers to be able to be building out your applications in such a way that they will fit, especially into a microservices construct. But, the split between that is that, if you are an application development team, you want to be focusing on delivering that value, delivering the applications themselves. And even if you are kind of rolling out changes, you want to be responsible for kind of the routing. You want to be responsible for that traffic management at the application level. You want to be able to get the observability and the metrics and things. But you still have to be able to have a team that's potentially looking after the service mesh itself. So you still have that operations layer. Now, the levels get much closer because you're talking about infrastructure as code. You're talking about Kubernetes containers, all of these sorts of things, which, there's sort of a joint responsibility running with, but you still have the teams who potentially will be looking and saying, are the components of the service mesh healthy? Because the application developers themselves probably don't want to have to look after that. They just want to be able to deploy their application, load balance traffic between their new deployments, for example, know when something's going wrong at the level of the application itself. So there is that, that's probably a reasonably clear split, even if it kind of moves up the stack a little bit. There's no longer managing servers or firewalls, especially in the cloud. You're having those operations teams running that level in between, and then the application teams running on top that are delivering value as quickly as they can, but there's an element of coordination to make sure that all of these sorts of things are running in the same way and working on the same platforms. It doesn't really get to that point that we see traditionally where it is applications team goes and says to the operations team, hey, I've got this application, you go and throw it out for me and tell me if it's rolling out correctly and things. Those days are sort of gone, I think.
Yeah, totally. I think in the DevOps world is a lot more about shared responsibility across all the different teams. Yeah. Okay, another question from audience is how do you compare serverless with Kubernetes and Istio? Like, what are the differences and any recommendations to when do we use service mesh and serverless?
So I think the discussion on Kubernetes and serverless, I think, is probably a reasonable comparison. The service mesh itself, I think, can work in any of those sorts of environments, whether or not it's your old mainframe on-prem somewhere, to your physical server sitting in a data center, to your virtual machine sitting in the cloud, to your containers which are running wherever it is, and then the kind of your serverless, your Lambdas, your functions as a service sitting in the cloud elsewhere. So there does need to be a glue across all of these sorts of things. So that's where service mesh can potentially come in there and be a benefit. And I think there's sort of the connectivity piece becomes very, very important, because you want to kind of abstract those differences away. If you're talking about services, it could be a small snippet of JavaScript that's living in a serverless function. It could be a big Java application living in a container somewhere. But at the end of the day, they're just services. So, in essence, you're having these kind of sidecar proxies that are sitting next to the services themselves and abstracting that connection piece away from things. Now, there are some nuances to that discussion, because serverless themselves is designed to be as small as possible. So these things can be can fit into a service mesh component without a service mesh. They can have egress services running across into different environments and things. But overall, there's sort of, these things kind of make sense of that aspect of it, that you have the connectivity piece of the service mesh that gives the security between the services, the visibility between the services, and the discovery as well. But the individual, a Lambda or a container is there to actually run the compute in a different way and independent of the network itself.
You mentioned about Envoy being used in AWS and Google. Like, are there any Azure solutions, or are there any compatibility issues with Azure with service mesh?
So I would have to say my knowledge of Azure's service mesh is not particularly great. As far as I'm aware, they don't have an equivalent offering to the other two. They have different types of services, and I know that HashiCorp has a managed service offering of Consul in that environment. But overall, Envoy itself will run anywhere. It'll run, from a Windows machine all the way through to Linux servers, to from very small footprint all the way up to very, very large. It's a very, very flexible piece of technology, so it can run in all of these sorts of environments. So there's no issue, I think, in running that. And I think the question then becomes, what's your control plane? What's your management plane that sits on top of that? And there are solutions that can be deployed in any of those things. It could be Istio running on top of the Azure Kubernetes servers. It could be running in virtual machines with Kuma or Consul. All of these sorts of things are completely and entirely possible in Azure or in any service provider, independent of the managed services themselves.
Okay, thank you. There's one more question on how does Docker play a role with the whole scheme of service mesh?
So I think Docker became quite a good enabler of this thing. And the reason why the sidecar proxy got its name sidecar proxy in some ways is because of the way that it was first implemented in Kubernetes, which is obviously using Docker under the hood. So the way that things would typically be done is that if you deployed your container, your application, which is just the application itself, behind the scenes, the service mesh, be it Istio or any of the others, would look at that container and say, okay, this is something that we want to put into the mesh. What we're going to do when it launches is it'll inject a sidecar proxy in there into that pod or that collection of containers. And so in that sense, they work very, very closely together. So in fact, Envoy in an Istio or another service mesh environment in that would in fact be living in a Docker container. Your application itself inside of Kubernetes would be living in a separate Docker container. They get glued together when you launch and then run together as part of the mesh itself. So then you just get service mesh next to service mesh in these containers as you start to sort of scale it out. And then the name kind of stuck as you say, well, we put it into a virtual machine itself. It's your sidecar, even if it's running outside of the sidecar, outside of Docker, although very capable of running inside of Docker, inside of a virtual machine, next to a legacy COTS application that hasn't been updated in 10 years. So that's the sort of differences that we see.
So one more question is on like, does a traditional 3-tier network architecture, does it still have a place in the world of service mesh?
I think it does. I mean, I think it really, at that point, you know, there are benefits that you see in terms of the observability and the failover and load balancing. I guess the question though is it too much infrastructure overhead if you have a fairly small 3-tier architecture? So, you know, I think if you're running multiple 3-tier architectures across different teams, be it different applications or different versions or environments, you know, that can make sense to have a sort of a centralized service mesh isolating each one of those different 3-tier applications. And, you know, then you're effectively centralizing the management plane, avoiding the overhead, but you still get the benefits of the kind of the monitoring and the security and connectivity. So yes, I think it can make sense in that. But if you're talking about a single environment, you know, if it's a WordPress blog, for example, or if it's a you know, very simple 3-tier application on it in its own, some benefits, but probably overkill to go and deploy it, a full service mesh net.
So we have one question on like, are there any security considerations such as two-way SSL provided by service mesh, or the developers have to take care of security in service mesh?
So part of the sort of the segmentation piece is that it takes care of a lot of those things themselves. Now, I briefly talked a little bit about SPIFFE, which is sort of a semi-standard that specifies how a PKI certificate should be created and distributed down to the workloads themselves. So, you know, that's actually taken care of by the service mesh. Most service meshes implement some form of SPIFFE. It's a standard that lives on its own as well. It also has an implementation on the side called Spire, which is less about networking, more about kind of identity and security. But overall, these sorts of things should be transparent to the service mesh itself. Now, because, you know, you're talking about a PKI infrastructure, you know, there is the consideration of securing the control plane. There is also the consideration of, well, do I generate my own certificates, or do I use, say, a corporate, you know, CA behind the scenes? All of these things are entirely possible. So, but as it gets down to the service mesh itself, part of the benefit really is that you don't have to think about the pipes between your services. That's taken care of by the service mesh. And, you know, it also then starts to look at the other parts of it as saying, well, look, I've got a certificate. What happens if it expires? Behind the scenes, the service mesh, the Envoy proxies will get a new certificate and then, you know, continue to operate as expected. So it is a nice benefit of being able to drop these sorts of things in, other than sort of just the guarantee of saying the two ends of the pipe are secure.
Mm-hmm. So one question from the audience is it like really worth to implement service mesh in production environments, since the traffic is going through too many proxy components that may increase the latency and response time to end user?
Yeah, so I think that's a really important consideration. I mean, that's why I sort of gave the caveat at the end of saying it's not magic. There are always trade-offs in any solution. Now, one of those is that there are proxies in between. Now, these proxies are generally one-to-one between a service. So the latency consideration is there, but it's not the sort of same as, jumping back to a central service somewhere else outside of the network and back again. It potentially remains inside your, your VPC or your network compartment itself. So, but it is still very much a consideration as to if you deploy it. Now, I would say that, it has benefit of deploying into production environment. If it, I don't think the service would really, or the technology it would really have lived if it didn't make sense running in production. But, like any piece of technology, you have to look at it and say, well, there is going to be a latency trade-off, but does that, is that compensated by the benefits that I get out of it? The security that I don't have to worry about as much, the operations and the monitoring to say, well, actually I get better visibility into the latency or the errors between my services. So that actually may compensate in some ways. On the other hand, if you're running a very highly latency sensitive service, it may be that you sort of say, okay, it's not for me. It doesn't make sense for my service because it is just too critical. Or you kind of consider the other approach of saying, can we disable certain features of the mesh to give greater functionality? Greater performance or greater, and part of that is saying, well, we can't get rid of the proxies because that's a fundamental piece of the communications part, but do we get rid of the certificates, for example? Do we look at how the traffic is running over the service mesh as layer 7? Can we downgrade it to layer 4? All of these sorts of things can be considered in that sense. So I think it does make sense to run it in production because of the operations and the visibility, especially at scale. But of course, it's that consideration of saying, this is what we need to really look at and evaluate as we consider any kind of technology.
And the question is like, does the service mesh work well with SDN, software-defined networking?
Yeah, it can, and I think you see a little bit of a convergence in that SDN sort of start to touch on aspects of service mesh. Although with a service mesh, it does live at a slightly different level than what we typically consider with an SDN. I mean, I think if you look at some SDNs, they're starting to go and say, can we get further up the stack? Can we provide the security between different virtual machines or different services? But overall, I think they can be considered at different layers of the stack, and there are different benefits at each one. So independently deploying as SDN and deploying a service mesh, I think, is probably separate considerations. And I suppose at the end of the day, if you look at who is responsible for an SDN, it is usually the network team. The service mesh itself, although the components may be managed by an operations team, the applications team is then the responsible one for the connectivity between the services and the availability and monitoring of those. So slightly different concerns there.
Okay, yeah, there are quite a number of good questions from the audience. So there's a few more. I think we're almost there. Does service mesh manage who can call a service?
Sorry?
Does service mesh manage who can call a service?
Yeah, it does. So I mean, I only very briefly touched on it, but there is a very strong component of the sort of the access control portion. So when we create ourselves an identity and one on the on a corresponding service, that doesn't necessarily mean you can guarantee that they're going to connect. Usually, what you'll need to do is have some kind of configuration that says service A can talk to service B. And then behind the scenes, the service mesh itself will make sure that those two services can actually send packets across the proxies to each other. So that's the sort of fundamental piece, and that gives a lot of granularity. So, I mean, if you think about what we have, in traditional network environments of firewalls having almost a sort of one-to-one relationship, the benefits that you get with the service discovery is that rather than just saying we have a fixed IP that's talking to a fixed IP, and we need to keep a table of, all of these other, that are potentially in a load balance, for example. All of these things are part of the discovery. So you can start to get into what we see, in some ways with cloud service providers, where you can start to do tagging. I would like to target all of these services that have a particular tag. I only want to target the ones that are healthy, or you know, to the extent of saying, okay, I want to be able to target these sorts of services that have a, you know, particular component running in them. And then on the other side of things is the traffic aspects of it, and saying we want to be able to route traffic to, you know, only 10% of these sorts of instances and 90%, or with this particular HTTP header that has a particular cookie, then I only want to send traffic to these sorts of things. So there's a lot of flexibility for both the routing aspects of it, but also, you know, overlaying and the connectivity, because underlying all of that, it makes sure that only those services can talk to each other.
And I'm not sure if there's a question there, like SPIFFE or PKI certs. I guess the question is to confirm, is SPIFFE or PKI certs?
Yes, it is. So they're effectively X509 certificates. So yes, very much traditional certificates that we're familiar with in, you know, in our network environments themselves. So they just have different names and, you know, parameters that are configured inside of it to give an identity to that workload itself, and they're configured dynamically for the service itself as it goes, you know, as it gets spun up or taken down or scaled out as well.
Okay, so two last questions. So load balancers and security, are they not baked into service mesh?
Sorry, it's at load balancers and
security.
I would say that they are baked in. I mean, just at a different level than what we're traditionally familiar with. So, you know, if we think about either load balancers as, you know, the network load balancers that we see in AWS, for example, or the physical load balancers that we see on-prem, you know, a lot of those sorts of things move up into the mesh. Now, where we see those sorts of things is sort of tracking health of the services running behind them, being able to do kind of rolling deploys across these sorts of things, or scaling out as the environments change. So all of these sorts of things fit in, and they fit in at the sort of levels that we see, either sort of a layer 4 load balancer, a layer 7 load balancer. There's all these sorts of elements that then can be tied in there. So yes, they definitely fit in there. As for an overlay on top of it, it is. So if you're using a service mesh, you can't necessarily get all of the benefits of an AWS ELB, for example.
It's 6 p.m.
Oh, 6 p.m. But in that case, yes. I mean, there's still, you know, the load balancers themselves, I think, potentially are less relevant because they are built into the service mesh itself. You also get the benefit of that sort of firewalling and segmentation that you see in network environments too, where it is very much true micro-segmentation, that it is a service to a service that can only talk to each other, or a service to a particular set of tagged instances or services that you know, are out of a, you know, in a load balancing group itself.
Okay, great. I think we are out of time, but one last question is on like, is there a shared responsibility model between service mesh and application team?
I think there always is, no matter which environment it is, and no matter what the technologies are, because in the stack that we're building, there is always this overlap. You know, there is the consideration that if you're running the platform, you know, that you need to be, you know, maintaining these things in a secure manner, which is a separate responsibility from the application teams running that. But then there is also this shared responsibility of saying, well, the certificates that are running across all of these sorts of things, you know, are touching on that they need to be valid, they need to be kept up to date, and they need to be managed in a responsible manner. Now, although some of these things are hidden for the application teams, they still get exposed as, you know, parts of the connectivity. So they do need to be managed well. And there is that kind of model of saying, well, you know, these sorts of teams do need to understand their boundaries and understand their scope, and to see where there's overlaps in terms of where the responsibilities lie in that sense. And there are definite parts of that. It's not a free ride, and it's not kind of magic either.
Okay, thanks a lot, Hunter. It has been a very insightful and useful talk. We have learned quite a bit. And thanks to our audience as well for a lot of questions and a lively participation. Thanks to our organizers, Catherine and Richard as well. So do take note of our upcoming events, which will be flashed on the screen. And there will be a post-event survey which will be sent to you as well. So do share your feedback with us. We would like to know how was your experience. And thanks a lot and have a great weekend. Happy Friday.
Thanks very much. Thanks for having me, everyone.
Thanks.